If you're doing digital marketing or direct mail, one of the key concepts to understand is A/B testing, and specifically, what is statistical significance? Here, we're looking at an example of some ads that we're currently running. And the question always comes up, which ad's performing better? How do I know? And when can we pause one and try a new test, promote one to being the core creative, and then move on to continue to iterate? Well, if you get this wrong, I would say you're just guessing. And so what I wanted to run through here is sort of the core concept around what is statistical significance and how much sample you actually need to understand how well your ads are converting or how well your direct mail is converting, and give you some tools that you can leverage in order to answer these questions reliably to make sure you're getting good results in your marketing. So let's quickly run through what Stat Sig means and how to think about this when you're actually making decisions. And the key thing here is before you make a data-driven decision, you must have certainty when making that decision. Otherwise, it's just guesswork and you're actually not going to get the results that you're looking for. Fundamentally speaking here, the larger the sample size, the more certainty you're going to have. But obviously, we want to make decisions quickly. We want to be able to iterate quickly, and we want to promote the winners fast and not let them linger too long. So the question is, how long do I need to wait? What size? What's the minimum sample size I need in order to make an informed, reliable, high certainty decision? So on the left here, we have essentially the same tests. And what it's looking at is a 500 sample size population compared to a 5,000 sample size population. I find the visual here really helpful because essentially what we're looking at is two conversion rates. The baseline is getting 10% and our test or variant in this example is getting 12%. Depending on the baseline conversion, this is really important in terms of how big of a sample size you need. Obviously, the more conversion, the more data you have in terms of what's doing well, meaning you need less of a sample to actually see an effect. The second question here is how big of an effect you want to see. Do you want to see that 10% go to 15%, or are you looking for 10% to go to 1%, and that's considered a winner? The degree of separation that you're looking for to identify a winner is key here in terms of, again, how big of a sample you need. So as you can see here, the 500 sample here, in this case, with a baseline conversion rate of 10% is not statistically significant. And what that means is you would not have a high degree of certainty of whether or not that variant is actually winning because there's too much noise in the data. You don't have enough separation or enough positive affirmations to say that, yes, that is a winner. And what's useful in the visualization is the overlapping curves is what tells you where you have an uncertainty. And specifically, because there's a large area under the curve that's overlapping here, that is essentially your uncertainty. You can't say with a high degree of confidence that that one's winning or not, because it is in fact actually better. If we look on the right-hand side here, this is our 5,000 sample, and this is where you start to see separation of the results. And you see a low or small area under the curve of overlapping data. And you can see separation in the population on the left and the population on the right that each received 5,000 views or impressions or whatever the scenario may be that you're looking at. And this example is statistically significant. I'm not going to get into all the technical nuances. I'm not a data scientist myself, but I know enough here to be dangerous. And at a high level, this is the concept that you need to be thinking about when you're trying to assess your A/B tests of whether or not it's a winner or a loser, or you just need to wait a little bit longer. At the bottom here, I've also included a couple links. These are the things I would go check out to convince yourself of this. There are several Stat Sig calculators out there where you simply just input the impressions or page views and then the conversions, whether it's clicks or whether it's form submissions or whatever it may be. That'll tell you what your baseline conversion rate is. It'll tell you what the variance conversion rate is. And then it's going to tell you if it's statistically significant or not based on all of those input variables. The other one, which I'll talk about here on the next slide, is essentially your minimum sample size. And so Optimizely has a really good tool for this. And these are fundamentally the characteristics that you need to identify. So the key question here is, what is the minimum sample size I need to see a 30% change on a 10% baseline conversion rate with a 95% level of confidence? The smaller change that you're looking for, let's say we're looking for a 10% change on a 10% conversion, the larger sample size you're going to need. If I'm looking for a huge change, I'm going to need a much smaller sample size because I need fewer data points to tell me that, yes, there is a big delta or big separation between those two. And then 95% confidence. So this is saying I have less than 5% margin for error in terms of the data and the error rate that could be occurring in whatever we're seeing. And 95% is typically the baseline that which you want to be using. You could also ratchet this down to 90%. If you're at 90%, again, same concept, you're going to need a much smaller sample size in order to see that effect. So again, in this example, baseline conversion is 10%. We're looking for a detectable effect, meaning an increase or decrease of 30%. So on 10%, we'd be looking for anything greater than going from a 10% conversion rate to a 13% conversion rate. And in the example I just provided with Google Ads, let's say you're looking at impressions relative to your actual clicks and then the actual click-through rate of that particular ad. And then if I want a 90% confidence interval or level of confidence on how real those results are, this calculator is telling us we need a sample size of 1,200 per variation. So going back to my previous example, we only had a couple hundred impressions. We can't make any decision on how well either of those are performing until we have a minimum of 1,200 impressions on each of those ad creatives before we would kill one or promote one to be the new core creative. So I hope that's helpful in how you think about running A/B tests and what Stat Sig means when you're making a decision. We all talk about being data-driven in our business and how we make decisions. The key here is you need to be data-driven with certainty, and you need to remove doubt, and you need to use tools like this to ensure that you're not making decisions based on noise or errors in the data on very low sample sizes, because one or two conversions could sway that stat massively. So the larger the sample size, the more certain you'll be able to be in your decision-making process. So hopefully that's helpful. I'm curious on how you guys apply this in your business. I would encourage you to play around with these calculators. If you apply this same methodology to things like direct mail, you'll notice you'll need massive sample sizes in order to see improvements in your creative and conversion, especially when you're dealing with conversion rates sub 1%. You need to see tens of thousands of records in most cases in order to see a detectable effect of something meaningful. Let me know if you have any questions on this. Would love to hear your feedback.